Okay, so today we're going to be talking about different forms of numbers. No, you do not need to write this on your sticky note. Okay, I will tell you when you write it on your sticky note. There are different forms of numbers. So, for example, we have standard form. Can somebody give me an example of a number in standard form? Oops.
1.
What's a number in standard form?
7.
7. Okay, what's another one? Haley, what's another number in standard form?
3.
Okay. Give me one that's in the thousands. Dalton.
7,000. 700.
7,280.
No, 7,000.
Okay. So those are all numbers in standard form. These are the ones that we typically work with. Okay, we also have expanded form, which you probably honestly haven't seen since 6th grade, because we don't typically write in standard form. In 5th and 6th grade, you did it so that you could understand the place values of numbers. So expanded form, if I was to write 7,280 in standard form, I would write 7 times, since the 7 is in the thousands place, I would take it times 1,000, plus 2 times, it's in the 100s place, so times 100, plus 8 times, it's in the tens place, so times 10. Okay, that's expanded form. Okay, what we are working with, don't worry, we're not writing an expanded form. What we're working with today is scientific notation. I do want you to write that down on your sticky note. Scientific notation.
At the top of the paper?
Yeah. There are some rules when writing in scientific notation. Our first rule is that our number has to be between 0 and 10. Is 0 between 0 and 10?
Yes.
No, 0 is 0, therefore it is not between. Is 10 in between 0 and 10?
Yes.
No, 10 is 10, therefore it is not in between. Okay, so your number cannot be 0 and your number cannot be 10. It has to be in between 0 and 10. Somebody give me an answer of a number between 0 and 10 that does not have a 7 in it. Van. 5. 5 is between 0 and 10. Someone give me a decimal that is in between 0 and 10. Caitlin. 1.5. Okay, so 1.5 is in between 0 and 10. Our second rule for scientific notation is that you're always going to multiply by a power of 10 with an exponent that is an integer. Somebody give me an example of an integer. Landon.
-7.
-7. Bailey. 5. Okay. Is 3.2 an integer?
Yeah. No.
No. 3.2 is a decimal. An integer has to be a positive or a negative whole number. Okay? So how can I write a power of 10 with an exponent that has an integer, Michaela? times 10 to the what? An integer. 10 to the second. Okay, this right here, 1.5 times 10 to the second is in scientific notation because the number 1.5 is between 0 and 10, and then it's multiplied by the power of 10 with an exponent that is an integer. So somebody give me another number that is between 0 and 10. Adriana.
0.
Yep, a number between that.
6.
6? Okay, so 6 times 10 to the, give me a negative exponent. Haley. Negative 4. So 6 times 10 to the negative 4 is written in scientific notation because the number is between 0 and 10 and the exponent is an integer. In your books on page 52, your example 1 is 5 3/34 times 10 to the what? 4th. Is that in standard form or scientific form? That's scientific form, right? Because my number is between 0 and 10, and then it's multiplied by a power of 10 with an exponent of an integer. If we're going to evaluate this, is my number going to be really big or really small, and how do you know? Tristan, what do you think?
Big.
Why do you think it's going to be big?
Because you're
Okay, and how do you know that I'm going to move it to the right?
because it is big.
Because I have a positive exponent, right? So if I have a positive exponent, my number is going to be big. So I'm going to move it how many times? I heard Tristan say he's going to move the decimal to the right, but how many times? Michaela? 4. And where'd you find that number? The exponent. So I move it 1, 2, 3, 4. And then what do I fill in? Zeros, right? Do you think I'm going to accept that work? No, that's messy. So we would rewrite it. Okay, so we have, and then you put your commas, so we would say that as 53,400. The top part is what notation? This is standard, scientific to standard. Okay, so positive exponent, you're going to get a bigger number. So then my second example is 3 2/27 times 10 to the what?
-3.
-3. Is my number going to be really big or really small?
Small.
How do you know?
Because it's negative.
So it's going to be small because I have a negative exponent. So which way am I going to move the decimal this time?
Left to the left.
To the left. How many times?
3.
How'd you figure that out?
Because it has a 3 exponent.
Because my exponent is 3. So I move it 1, 2, 3. What do I fill in?
Zeros.
Okay. So would I accept an answer like this? Michaela, you said no. Why not? I need a 0 to be mathematically correct in front. Okay? Questions about this? Example 3, we're given what type of form?
Scientific.
No.
Yeah.
Standard.
Standard form. So I need to turn it into
Scientific.
scientific. Okay? How am I going to make this a number so that it is between 0 and 10? How do I make it a number in between 0 and 10? Move the decimal. How many times do I need to move the decimal so that I get a number between 0 and 10?
-6.
Well, leave out the negative right now.
6.
6, right? So I move it 1, 2, 3, 4, 5, 6. So now I have 3.725. Do I need to write those zeros?
No.
Did I have to write the 725 though?
Yes.
Yes. Okay, I don't need the zeros though. So then we're going to multiply it times the power of 10. Faith, why are you saying negative?
Because we have to move
Okay, but is my number big or small?
Humongous.
My number's what?
big.
Big. So should my number be positive or negative?
Positive.
Positive, and how many times did we move the decimal? 6. So times 10 to the 6.
I knew that.
Okay, so then if we look at this one, I have a decimal. I need to move it so that I get a number that gives me between 0 and 10. So I would get 3.16, right? Times 10. How many times did we move it? And is it going to be positive or negative?
Negative.
Negative because my number is small. Questions? So it's the opposite of what we did before. So now we're given standard and we have to make it into scientific. Okay.